Good morning everyone. Today we will be learning about instruction codes. Instructions code is a set of binary bits which decides the micro operation to be performed by the computer system. Basically, these instruction codes are stored in the memory. Instruction code is totally made of three parts. They are operation code, address bits, and addressing mode. Operation code is also known as opcode, which is of 3 bits. Address bits is of 12 bits. Decides the address of that particular instruction code. In memory, there are total of 4096 words, which is of address bits each of 12 bits. Addressing mode is of 1 bit, which can either be 0 or 1. When the addressing mode is 0, it is direct addressing, and when the addressing bit is 1, it is indirect addressing. We shall be learning about direct and indirect addressing soon. In total, the instruction code is of 16 bits. Declaration of instruction code is of 3 types: memory reference, register reference, and input-output reference. We shall be learning about these in detail later. This is the pictorial representation of instruction code comprising of address bits, opcode, and addressing mode. You should also remember that the instruction code is stored in the instruction register. Now let us understand the addressing mode. The addressing mode decides the method by which we can obtain the operand for operation to be performed. The place where we can find the operand is known as target of destination, that is the effective address. There are 2 types of addressing mode: direct and indirect. Direct addressing mode is where we find the address of the operand directly. Indirect addressing mode is where we find the address of another address where we find the operand. This way, the address which has been found first is the pointer to the address where the operand is to be found. Effective address is where we find the operand for which the operation is to be performed. This is also the final destination. Opcode is a set of binary bits which decides the operation to be performed on the operand found. The number of bits of opcode is decided on the number of operations which can be performed on the operand. This is the formula to find the opcode number of bits. Let us remember that the opcode number of bits is half of the number of operations performed on the operand. Every instruction code is placed on a stack-like figure for which each instruction code consists of particular address. These address can consist of another address or the operand itself. Based on this method, there are 2 types of address: direct and indirect address. Direct address is where we find the operand directly by the address provided in the address field. Indirect address is where we find the address which acts as a pointer to find another address which in turn finds the operand. In this case, the effective address is 300. In this case, the effective address is 1200 and pointer address is 200. Let us not get confused on addressing mode and address. Addressing mode is a 1-bit deciding factor which decides between direct and indirect addressing. In this case, the addressing mode is 0, which says that it is direct addressing mode. In this case, the addressing mode is 1, which says that it is indirect addressing mode. Let us understand how instruction code is used in 3 types. Now let us learn the basic 3 instruction registers: memory reference, register reference, and input-output reference. Under memory reference, the data bits provided in the address field is the operand. In case of register reference, the data bits provided is related to the register which consists of data bits where the operand is found. In this case, the operand is not directly found, whereas it finds the register details which consist of operand. Input-output reference register, which act as a communication device between the outside device and the computer system. The operand act as accumulator where the operand bits can be found. Under memory reference, the address bits of 12 bits consist of the address. 3-bit part consists of opcode. Every bit combination of 3 bits is of total 8. The combination of 3-1 will be not used in opcode under memory reference, and the remaining 1 bit consists of addressing mode bit in memory reference. Here is the pictorial representation of memory reference instruction code. 12 bits address part of register reference consists of the register operation to be performed on the operand. 3-bit opcode is always 111 in case of register reference, and in 1-bit addressing mode is always 0, indicating direct addressing. Here is a pictorial representation of register reference instruction code. In case of input-output reference, the 12-bit address consists of input-output operation to be performed on the operand. Here also, the 3-bit opcode is always of 111. But unlike in case of input-output reference, the addressing mode is of indirect, indicating 1. This is a pictorial representation of input-output reference. These are the set of instructions which can be performed on the operand found using instruction codes. Arithmetic, logical, and shift operation, comprising basic operations like addition, subtraction, complement, left shift, and right shift. Then transfer operation, comprising store and load operation. Under store operation, the operation bits or the operand bits are stored in the particular instruction code. The load operation is where the binary bits or the resultant of the operation performed is stored in the memory. Program control with status. We shall be learning about this in detail in further sessions. Input and output operations, which indicates the operand bits is input or output. So friends, we shall be learning about further topics in the later session. Till then, stay tuned. Thank you.